Okay, then let's start for today's lecture. So, good morning, everyone. In last lecture, we have studied the electric field intensity, right? So, electric field intensity is denoted by a capital letter E, right? And it is a vector quantity. And electric field intensity is derived from the force that we have obtained in Coulomb's law, right? In Coulomb's law, we have studied like there exists a force, and the force is directly proportional to product of charges and inversely proportional to square of distance between the charges, right? So we got the force, and yesterday we have defined electric field intensity as a we have defined now. So electric field intensity is defined as force per unit charge, right? So if we do that, we will get the equation for electric field intensity, right? So in simple words, electric field intensity is force per unit charge, force F divided by Q, right? So in that respect, we have, let me take, just to recall quickly, from Coulomb's law, we have defined this force. We have defined force. Just a minute. So from Coulomb's law, we have defined force, right? So force F bar is equal to Q1, Q2 upon 4 pi epsilon naught R square A bar R, right? So this is what general definition of Coulomb's law, mathematical expression for Coulomb's law is. Now, after studying this, this is true for two charges, like you have Q1, you have Q2 here, right? So for those two charges, we can write this as a force between those two charges, right? Now we have extended this idea to electric field intensity, and electric field intensity is denoted by capital E, and it is also a vector quantity. Direction of electric field intensity is same as that of force, right? And here in this case, we have taken one of them as a source charge, let us say Q, and one of them is taken as test charge, let's say small q, right? This is your test charge, and this is the source charge, right? So because of source charge, how much electric field intensity is experienced by test charge, that we are going to calculate. And as per the definition, yesterday we have seen that it is equal to force per unit charge. So we have force as F bar and charge, test charge as small q, right? So this is equation 1, this is equation 2. So what we have to do is, equation 1 I can write in this scenario. How I can write? This has to be q and this has to be small q. Right, here also I will modify accordingly. Right. So if I put the value of F bar from equation 1 into equation 2, what I will get is electric field intensity E bar is equal to, it is equal to capital Q small q divided by Q 4 pi epsilon naught R square A bar R. Now this Q gets cancelled. So what is remaining? Electric field intensity E bar is equal to Q upon 4 pi epsilon naught R square A bar R, right? So this is what the expression we have seen for electric field intensity. Very, very important mathematical expression for electric field intensity. Unit of this electric field intensity is volts per meter. Is that clear? That is what we have seen up till now. Right, so let's move ahead. Yesterday we have solved one of the example, if you could remember. So what was that example? You need to find the electric field intensity at a given point because of some point charge. A very similar example I am going to solve today also. So let's go ahead. Right, so the example is let a point charge q equals to 60 nanocoulomb located at -3, comma 4, comma -2. So this is the location of charge, and find electric field intensity at find E bar at, the point is given, let's say 1, 2, 3. E bar at 1, 2, 3. So let us define this point as point P. Right? So this is the example. Is it visible? Am I audible? Someone respond?
Yes, sir.
Okay. So the problem is there in front of you. You just try on solving this example. It is very, very similar to the example which we have solved yesterday. By the time I will take the attendance, you can proceed to solve this example. Roll number 24. 24 is present. 24. 29. Roll number 29. 32. Roll number 32. Roll number 34. 35. 36. 37. Roll number 40. 41. 43. 46. 48. 49, 51, right? So in last lecture, we have solved this similar type of example. So today we are going to solve this example, which is totally based on electric field intensity to calculate the electric field intensity. And basically, we are assuming a given of medium is a free space. So for free space, permittivity is 8.854 into 10 raised to minus 12 farad per meter, or you can consider it as a 10 raised to minus 9 upon 36 pi, right? So for this given thing, let us draw, because this is the first step. So let's draw the picture of this. So here you are having a charge Q, right? So what is the value of Q? Where it is located? It is located at -3, comma 4, comma -2. This is the location, and what is the value? It's 60 nano coulomb, right? So this is Q, and because of Q, there exists the electric field intensity, and they have asked you to find out the electric field intensity at point P, where the coordinates of point P are 1, 2, 3, right? Very similar example we have taken. So we will draw the vector first, right? So this is going to be a vector. Let us treat that vector as r bar. This is vector r bar, and in this direction you will have unit vector a bar r. So this is the first step. Second step is to calculate the vector and magnitude and unit vector. So vector is r bar. So here I am calculating vector. R bar is equal to, can someone tell? R bar is equal to 1 minus of -3.
1 plus 3.
Yes. 1 minus of -3 means 1 plus 3 a bar x. Next.
2 minus 4 a bar y.
2 minus 4 a bar y, correct. Plus
3 plus 2 a bar z.
3 plus 2 a bar z, correct, absolutely correct. So final vector that you get here is 4 a bar x minus 2 a bar y minus 2 a bar y plus 5 a bar z plus 5 a bar z, right? Then we have magnitude of vector r bar. It is equal to under root 4 square plus in bracket minus 2 raised to 2 5 square, right? So what is the answer of this? Under root
45.
45. So therefore I can write here a bar r, that is unit vector. Unit vector a bar r is equal to 4 a bar x minus 2 a bar y. We know that this vector is unit vector, and unit vector is nothing but vector upon magnitude. So this is vector, and divided by magnitude is under root 45, right? So this is unit vector. Now we got this vector, magnitude, and unit vector. Now last step, step 3 is to use the formula, right? So use the formula of electric field intensity to calculate electric field at given point. So E bar at P is equal to, formula is Q upon 4 pi epsilon naught R square A bar R, right? So this is equal to, so let us put on the values. All the values are to be written here. Q, value of Q is 60 nanocoulomb. 60 nanocoulomb means 60 into 10 raised to minus 9. Then we have 4 pi divided by 4 pi epsilon naught. So 4 pi as it is. Here I will use 10 raised to minus 9 upon 36 pi as a value of permittivity. 36 pi into under root 45 bracket square. Right, because R is under root 45. So this is the thing. Then we have A bar R unit vector. So 4 A bar X minus 2 A bar Y plus 5 A bar Z plus 5 A bar Z divided by under root 45. So turn on your calculator and just calculate this thing. And tell me the value here.
1.788.
Correct. 1.788. This is equal to 1.788. This is the value, and we have the vector as it is 4 A bar X. Now you can get this constant multiplied with the vector minus 2 A bar Y plus 5 A bar Z. So final answer, E bar at P. E bar at P. It is equal to 7.14. Yes.
152 A bar X
A bar X. Okay. Go ahead.
plus 3.576 A bar Y
Plus or minus?
minus
Minus 3.5.
76 A bar Y
76 A bar Y. Okay.
plus 8.94 A bar Z.
8.94 A bar Z. Don't forget to put the unit. Unit is volts per meter.
Meter.
So this is the final answer. I hope you have noted the answer. Right. So variety of equations, variety of examples are there. So we will be solving those examples in tutorial. So today we can proceed further to understand the theoretical part. Okay, that's fine. Or shall I give you one homework?
Yes, sir.
Okay. Okay, so take this as a homework. Homework will always be written in red color. So here you have point charges of of 120 nanocoulomb each 120 nanocoulomb each are located at let's say point A. Here I will write it as 0, 0, 1 and B at 0, 0, -1 in free space. Find vector E bar at find E bar at 0, 0.5, 0. Try to understand the example, what things are given, and what I'll do is I will help you in the first step. First step is to draw the given diagram, right? So to draw the given information with a neat sketch. So let's have this as a z-axis. Let us assume this is the z-axis. This is your z-axis. So on this axis, you may have a point called as 0, 0, 1 somewhere here. So this would be your 0, 0, 1. And you would be having another point called as a 0, 0, -1 somewhere here. Right? And because of this, you have to find the electric field intensity at a point somewhere on a y-axis. So let me draw the y-axis also. So this is your y-axis, right? Let's say this is y. And on this y-axis, you will have a point called as, let's say, 0, 0.5, 0. Right? So you have to find the electric field intensity at this point. You have to find the electric field intensity at this point because of those two charges. You are having Q1 here, right? Let us assume this as Q1. What is the value of Q1? Q1 is having a charge of 120 nanocoulomb. 120 nanocoulomb is present at this point. Let us say the Q2, which is present over here, let us say its value is also 120 nanocoulomb. And because of those two charges, how much is the electric field intensity produced at this third point? That you have to calculate. So this is first electric field and this is second electric field, right? So you have to find these electric fields. So let's say this is R1 and this is R2, right? So here as an answer to this, you have electric field intensity E bar total is equal to, as per principle of superposition, E1 bar plus E2 bar, right? So E1 plus E2. And you know the formula for E1 and E2. What is that? E1 bar is equal to Q1 upon 4 pi epsilon naught R1 square and A bar R1. So this is the formula by using which you can calculate E1. Then you have E2. E2 bar is equal to Q2 upon, ते झालं का कॉपी प्ले होत आहे का व्हिडिओ प्ले होता ना कलर डॉपलरचा हाँ Q2 4 pi epsilon naught R2 square A bar R2. So these are the two equations by using which you can find the value of E1 and E2. Finally, you can put the values into this equation and you can obtain the total electric field intensity at a given point. I hope there will not be any ambiguity, there will not be any difficulty now. Solve करता येईल, screenshot काढून घ्या, solve करा. I will give you the answer for this tomorrow. We will cross check whether you got the same answer or not. Is it okay? Is it okay?
Okay.
Okay, fine. Okay. Now next point is for various charge distributions, how we can calculate the electric field intensity. So here is the heading. You can say calculation of electric field intensity for various charge distributions. Calculation of, let's say in short, E bar, electric field intensity for various charge distribution. बघा आपल्याकडे वेरियस चार्जेस आहेत, म्हणजे लाईन चार्ज आहे, सरफेस चार्ज आहे, व्हॉल्यूम चार्ज आहे. ते जर दिले असतील तर इलेक्ट्रिक फील्ड इंटेन्सिटी कशी कॅल्क्युलेट करायची, हा आपला डिस्कशनचा पॉइंट आहे. सो वी हॅव द इलेक्ट्रिक फील्ड इंटेन्सिटी ड्यू टू पॉइंट चार्ज, राइट? लेट मी राइट हियर. We have, what we have is electric field intensity due to a point charge, right? So what is the expression for this electric field intensity due to a point charge? It's a electric field intensity E bar, which is equal to, it is corresponds to a point charge Q upon 4 pi epsilon naught R square A bar R, right? So this is the scenario, this is the case when we consider a point charge as a source charge. So this is your source charge, and this is a point where you are conducting the test, right? So if you want to find this source electric field intensity due to this source at this test charge, you can use this formula. E bar is equal to Q upon 4 pi epsilon naught R square A bar R. You can directly use that formula. But what will happen if there exists a line charge, or there's a, let's say, surface, or let's say there exists a volume? In that case, how you can find out the electric field intensity because of those surface or volume at this test charge? So that's why we are having this discussion, right? So for point charge, it is very easy. But if they have mentioned some other charge configuration, in that case, what is to be done? So we have to follow certain steps. In that, step number 1 is step number 1. What step number is? Step number 1 is create a small charge dq. Create a small charge dq. Small charge dq using the expression the expression. So what would be the expression now? If it is for line charge, then dq is equal to rho l dl. Rho l dl. This is for line charge. dq is equal to rho l dl. This is for line charge. We have studied this line charge configuration. In that, dq is equal to rho l dl. dq is differential charge. Rho l is the line charge density. dl is the differential length. Right? Then for surface charge, dq is equal to rho s ds. Rho s ds. So in this case, we call it as a surface charge configuration, and this dq is differential charge, rho s is surface charge density, and ds is differential area. Similarly, for volume charge, we can have this dq as rho v dv. Rho v dv. This is for volume charge configuration, right? So dq is equal to rho v dv. In that, dq is differential charge, rho v is surface volume charge density, and dv is differential volume. So by using those three expressions, you can get the corresponding differential charge. Corresponding differential charge can be obtained depending upon the charge configuration. म्हणजे जर तुमचा लाईन चार्ज असेल तर तुम्ही हे इक्वेशन 1 वापरायचं. जर तिथं सरफेस चार्ज असेल तर इक्वेशन 2 वापरायचं. व्हॉल्यूम चार्ज असेल तर इक्वेशन 3 वापरायचं. ठीक आहे. So these are the equations you have to use appropriately. Now step 2. Step 2. What is step 2? Consider that small charge. Consider that small charge as a point charge, as a point charge. And find differential electric field. Differential electric field. आता ही कशी काढायची? जसं मी आता सांगितलं तुम्हाला की इथं जर तुमचा टेस्ट पॉइंट आहे आणि तुम्ही लाईन चार्ज मुळे जी काही इलेक्ट्रिक फील्ड इंटेन्सिटी जनरेट होतीये किंवा सरफेस चार्ज मुळे जी काही इलेक्ट्रिक फील्ड इंटेन्सिटी क्रिएट होतीये किंवा व्हॉल्यूम चार्ज मुळे जी काही इलेक्ट्रिक फील्ड इंटेन्सिटी क्रिएट होतीये, हे जर तुम्हाला कॅल्क्युलेट करायचं असेल तर त्याचा तुम्हाला छोटासा भाग घ्यायचा आहे. जसं आपण स्टेप 1 मध्ये शिकलो, त्याला डिफरन्शियल चार्ज डीक्यू म्हणा. इथं सुद्धा तो डीक्यू असेल किंवा इथं सुद्धा तो डीक्यू असेल. राईट. ह्या डीक्यू साठी आपल्याला डिफरन्शियल इलेक्ट्रिक फील्ड कॅल्क्युलेट करायची आहे. ती डिफरन्शियल इलेक्ट्रिक फील्ड असेल डीई बार. डिफरन्शियल इलेक्ट्रिक फील्ड डीई बार. त्या छोट्याशा भागासाठी जी काही इलेक्ट्रिक फील्ड असेल ती डीई बार असेल. आणि डीक्यू अपॉन उरलेला फॉर्म्युला सेम असेल जसं आपण सुरुवात केली ती 4 पाय एप्सिलॉन नॉट आर स्क्वेअर ए बार आर. पॉइंट चार्ज साठी आपल्याला इक्वेशन रेडीली अवेलेबल आहे. आपण काय करतोय हे लक्षात घ्या, म्हणजे तुम्हाला हे समजेल की कशासाठी आपण हे करायला लागलेलो आहे. पॉइंट चार्ज जे आहे त्यासाठी हा फॉर्म्युला आपण डायरेक्ट वापरू शकतो, पण जर लाईन चार्ज, सरफेस चार्ज किंवा व्हॉल्यूम चार्ज असेल तर हा फॉर्म्युला कसा वापरायचा. त्यासाठी आपण काय केलं, त्या लाईन चार्ज वरचा किंवा सरफेस चार्ज वरचा किंवा व्हॉल्यूम चार्ज वरचा छोटासा भाग म्हणजे स्मॉल चार्ज वी हॅव कन्सिडर्ड बाय युजिंग दीज इक्वेशन्स. म्हणजेच काय, डीक्यू साठी लाईन चार्ज साठी हा फॉर्म्युला, सरफेस चार्ज साठी हा फॉर्म्युला आणि व्हॉल्यूम चार्ज साठी हा तिसरा फॉर्म्युला. आणि ते वापरून आपण डिफरन्शियल इलेक्ट्रिक फील्ड इंटेन्सिटी कॅल्क्युलेट केली स्टेप 2 मध्ये. आता स्टेप 3 काय असणार आहे, कुणाला सांगता येईल? What would be the step 3? आपल्याला डिफरन्शियल इलेक्ट्रिक फील्ड भेटली.
टोटल इलेक्ट्रिक फील्ड काढायची.
येस, टोटल इलेक्ट्रिक फील्ड काढायची आणि ती टोटल इलेक्ट्रिक फील्ड काढण्यासाठी आपल्याला त्याला इंटिग्रेट करावं लागेल. ठीक आहे. इंटिग्रेट करताना पण मी सांगितलं तुम्हाला, लाईन चार्ज असेल तर सिंगल इंटिग्रेशन, सरफेस चार्ज असेल तर डबल इंटिग्रेशन आणि व्हॉल्यूम चार्ज असेल तर ट्रिपल इंटिग्रेशन. ठीक आहे. So this much understanding, I hope it is sufficient to solve any such example. मी तर step 3 लिहितो. Step 3, right? Integrate dE bar. Integrate dE bar to get total electric field. To get total electric field, or you can say E bar. So I hope you understood all the 3 steps. If it is clear, just a minute. If it is clear, then we will go ahead to solve one or two examples based on this concept. Right, so let us solve one example. Find electric field intensity. I hope everyone is ready with me because I have unsolved example. So you are ready with the calculator. This is my assumption. Find E bar at, let's say point P, 2, 3, 7. Right. So find E bar at P due to just a minute. I'll take a reference. Okay, electric field intensity due to infinite line charge, infinite sheet charge. These two cases we can consider. Okay. One formula is to be derived before that. Let it be. We will solve for a point charge only, and today's steps we will go ahead because it will take a time, and before that we need to understand one expression as well. So due to Q1 is equal to, let's say, 10 nanocoulomb at, let's say, 1, 2, 3. Here we have Q2 equal to, let's say, 20 microcoulomb at 20 microcoulomb at, let's say it's 2, 5, 6, and Q3 is equal to 10 millicoulomb at -2, 3, 4. Right. So we have three configurations, three point charges. And because of those 3-point charges, you need to find the electric field intensity at point P. So this is your point. We are not following those steps because see, this require one more understanding, and which is not possible to do it in 10 minutes. So what we will do is we will derive one equation first in the next lecture, and then we will solve the equations examples related to line charge and surface charge. So for a while we will consider only a point charges. Right. So you are having a point somewhere here. This is point P. What are the coordinates of point P? It's 2, 3, 7. Right. And you are having three charges randomly spread. Q1 located at what value? Located at which location? 1, 2, 3. Q2 is at 2, 5, 6. And Q3 is located at -2, 3, 4. Right. So you have to find out the electric field intensity due to Q1, the electric field intensity due to Q2, and the electric field intensity due to Q3. Right. So all the electric field intensities are to be calculated. So this is first, this is second, and this is third. So let us treat this as R1 bar. Let us treat this as R2 bar, and treat this as R3 bar. Right. So for this case, what I have to write here, total electric field intensity at P. So E bar at P is equal to what I can write, E1 plus, this is as per superposition, E1 plus E2 plus E3. Right. Now, first thing is to calculate E1. To find E1, what I need is R1. R1 is equal to 2 minus 1. It's A bar X. Then 3 minus 2. It's A bar Y. Plus 7 minus 3. It's 4 A bar Z. So you got R1. Now you have to find the magnitude of R1. R1 bar is equal to under root. How much it would be? 1 square plus 1 square plus 4 square. Right. So how much it will be?
Under root 18.
Under root 18. Correct. And you can write this as A bar R1. A bar R1 is equal to A bar X plus A bar Y plus 4 A bar Z divided by under root 18. Right. So you can use the formula for E1. It is equal to Q1 upon 4 pi epsilon naught R1 square A bar R1. So this is equal to Q1. Value of Q1 is 10 nanocoulomb. So 10 nanocoulomb means 10 into 10 raised to minus 9 divided by 4 pi epsilon naught. Epsilon naught means value of epsilon naught is
10 raised to minus 9 divided by 36 pi.
36 pi. Correct. Into under root 18 bracket square into A bar R1. A bar R1 is A bar X plus A bar Y plus 4 A bar Z divided by under root 18. Now you have to do this calculation and tell me the final answer. So first of all, you can calculate this part. Plus 4a bar z. So tell me, what should I write in the brackets?
1.178.
1.178. Okay, so it's 1.178 a bar x plus 1.178 1.178 a bar y plus, can someone tell?
4.712.
0.712 a bar z. Yes,
Oh,
so this is the final answer for E1, and we know that the unit is volts per meter. So this way you can find out E2, E2 bar, E2 at P, and find out E3 at P. Start solving and tell me the answer of those two, E1 and E2 and E3 at point P. Once you get the answer, you please tell me. काय the answer? What answer you are getting? Can someone?
34.64K.
30.
4.64K.
34.64K.
64K.
34.64K A bar X. What
The
here?
zero is for A bar X.
Huh? Here I am asking E2. E2 ची व्हॅल्यू सांगा मला. E2. E2 ची व्हॅल्यू किती आली आहे? हॅलो. हॅलो. बघा आपण इथं एक सॉल्व केलेला
Zero.
आहे. हा.
0 A bar X minus 69.28K A bar Y plus
हे
30.
0 A bar X येत आहे का? नाही लिहिले
हा,
तरी चालतंय. हा प्लस
69.28K A bar Y.
के येत आहे का? ए बार.
हाँ सर.
हा प्लस
34.64K A bar Z volt per meter.
के ए बार झेड वोल्ट पर मीटर. मग हे जे के आहे ते मी आतमध्ये लिहिण्यापेक्षा इथं लिहिलं तर बाहेर किलो वोल्ट पर मीटर लिहिलं तर चालेल ना?
हो सर.
हा किलो वोल्ट पर मीटर. आणि त्याच्यानंतर E3 सॉल्व केलाय.
करायला सर.
ठीक आहे, करून घ्या सॉल्व. आणि उद्या काय करू मग आपण यांची ऍडिशन करून फायनल आन्सर काढूयात. राईट. ठीक आहे. चलो. सो लेट कमर्स कुणी आलेत का? लेट मी रीड द ऍबसेंट नंबर्स वन्स अगेन सो दॅट absent numbers 24, 29. Let me check. "24" is present now. 24 आलेले आहेत. 29 नाहीतच. 32 आलेत का? 32. 34 नाही. 35 नाही. 36 आहेत. 37 पण आहे. 40 नाही. 41 पण नाही. 43 नाही. 46, 48, 49, 51. Okay, fine. ठीक है. So we will stop here. You are allowed to leave the meeting now.